Today, the plan is to go through some of the trickiest questions that students have sent in to me. And I've also come prepared with a handful of questions that I know people commonly get tripped up on when they're doing past papers. We're going to be doing questions across standard, advanced, and extension 1. Plus, if anyone drops any other questions during the live, I'm happy to go through them too. We'll just get started in a moment, and we'll kick it off with a standard question. Now, to do that, we basically want to find the sum of the weights of the edges that it passes through. But there's one condition. Now, I use a bit of an analogy to work out which ones to do count. It's a bit abstract, but imagine we're driving a car, right? I'm not a great drawer or anything, but imagine we're driving the car, right? In a car, in Australia at least, on the right-hand side we have the driver, and on the left-hand side we have the passenger. Now, our goal is to drive from the bottom of our network to the top. And we're going to follow the dotted line here, this cut. And while we pass along the cut, we are going to sum up any line that hits us through the passenger side door. Now, I'll give you a moment to sort of visualize that. So we're going to drive along the route. Anything that hits the passenger side door, or essentially the left-hand side of our car, we're going to sum up. Anything that hits the driver's side, we ignore. So, we're going to come up here, and as we come up here, you can see that from C to B, we are hit on the left-hand side, indicated by the arrow. That's the passenger side, so we're going to add that. That's 10. And we're going to keep going. We're going to follow the line. We're going to orientate the car as we go. When we hit this one, the D to C edge, notice how it's going to hit the driver's side. It's coming on the right. Because of that, we're simply going to ignore it. All right, and then we're going to keep going. Eventually, we're going to reach the source to D edge. And this one hits the passenger side again, to the left. So that's another 20. Okay. And we're going to get to the last one, the source to A. It hits the left-hand side, and we're going to take that at 10 too. Okay, and then we've hit the top. We've gotten across the entire network. So the weight of our cut is the sum of this, which is 10 plus 20 plus 10 equals 40. All right, and that is essentially the flow capacity. That is the same thing. So the answer for this question is 40. All right, now we're going to come over to part 2. And they're asking us to now work out, why is the network's current max flow less than 40? So if you have a look, the source has 10, 20, so 10, 30, and 40 coming out of it, okay? And at the other side of the sink, we've got 20 and 20, so 40 coming out of it. So you can think of a network like this as like a black box. And whatever goes into it, there's some sort of, machinery that's going on, and then something's coming out of it. Now, in theory, if we're having 40 going in and space for 40 to go out, we would expect 40 to go through the whole thing. However, and what we'll find out, is that this is not what happens in reality. 40 goes in, but less than 40 comes out. And the way that we can check this is by finding the minimum cut. So there's this thing called the minimum cut max flow theorem. Okay, and it's pretty self-explanatory off the name. The minimum cut just so happens to be the maximum flow that goes through the network. So if we can find a cut that is less than 40, that is how much is actually coming out at the end. Now, with a question like this, unfortunately, it can be a bit tedious. You essentially want to make you have to do all the cuts you can and find the minimum. So I'm just going to start here, and I'm going to make a cut like this. And I like to label them so we can keep track of what's going on. Now, if we look at C1, remember we're following the car technique from before. This is going to be 10 plus 20 is 30, plus 10, 40. Okay, so that one doesn't do anything. The next cut we want to do, I like to be methodical about it. We're going to take every left we can until we've exhausted all our options. So we're going to come up here, and that's 10. hitting this edge again, that's now 30. We're going to go through here, and remember, this is hitting the driver's side, so it's not going to count. So it's still 30, and we're going to come out the top to get a total of 45. All right, and if we're being super methodical, we would want to go here next as well. Right, but we're going to find this is obviously exceeding 40. 10, 30, that doesn't count either. 40, 60. Okay, so sometimes when they're very obviously going to be over, if you want to save time, you can skip it. So now I'm going to come over to the middle bit. I'll use a different color to be less confusing. And I'm going to come here. 10, that is the driver, we don't count it. 30, we got there, that's 40. Now if we go this way and start doing these paths as well, we're going to find again that it's all going to exceed 40. Okay, and you can kind of just try and think ahead there and notice that. The next one I'll try is up this way. It's a slightly different route. So that's 10. Going there, that's hitting the driver's side, so we're not going to count it. That's 20 now, and up the top, that's 35. That's the first one that we found that's below 40. Now, you can go ahead and do the rest, and they are all 40 or above. Typically with a question like this, there's not going to be too many that are below the intended max flow. The intended inflow and outflow. So just to save time, that is the minimum cut. So we can come back here and we can say, okay, the minimum cut equals 35. Therefore, remember the 3 dots here means therefore, the maximum flow capacity is 35, right? And for a question like this, it's good practice to see if there's any units involved. So sometimes it's talking about water, it could be gas or people. So we want to explain, okay, it's 35 liters per hour or people per hour. In this question in particular, it's talking about visitors. So we could say the current max flow capacity is 35 visitors. And let's see. Yeah, it doesn't say anything about the timings, so we can just say 35 visitors. That's the end of that question. C is where it gets tricky, and I feel like this is where there's the most sort of confusion by students. And it's asking, we want to increase one path so that the capacity of the entire thing ends up being 40. Which path would you increase, and by how much? So it's basically saying, imagine we had this network in real life, and you could do some sort of upgrade to it, and it would fix the max flow. So since we want the max flow here to be 40, that means the minimum cut also has to be 40 by this min cut max flow theorem. So that means we need to fix something along this minimum cut. My method that I like to do here is to draw up a table. And I'll just sort of show you. We're going to include a few things. So firstly, we're going to include the vertex. So remember, vertices are the different points along here. I'm also going to add a column for the inflow to that, the outflow, the excess. I'll explain all these in a minute. And then I like to add one called the type. All right, so I'll just, it's not the neatest, but remember, sometimes it's just about getting the answer right and doing it in a quick manner. So we set up this table. Now, what we're going to do is we're going to add a row for every vertex of the edges in the cut. So bear with me for a moment. So notice how our cut 5 was the minimum cut, and that includes this CB line, the DB line, the DE line, and the AE line. Now we're going to write down all the edges, all the vertices along these edges. So down here, A, E, D, B, and C. Okay. Next, we're going to analyze the inflow to each edge. So notice how at all these points, we've got stuff coming in and stuff coming out. I'll show you the unannotated one because I understand it's a bit busy. So if you look at this one, right, let's look at A. We've got 10 going in from there and 10 going in from there. So the total inflow is 20. So 20 people are going towards A. So I'm going to chuck that down here as the inflow. And then we'll go back to that diagram. Looking at A, there are 15 coming out. That's the outflow from that vertex. So that's 15 there. Now notice how they're not the same. So that the excess, or the difference between them, is 5. And the way, where the excess is matters. So notice how there's more people going in than out. We're going to call that a bottleneck. Okay? You might have heard that term before. Think about like a road, right? You've ever seen like a busy intersection? Because lots of cars are coming in and maybe not enough cars are able to get out during the lights, causing traffic. That'd be because it's a bottleneck. So the same thing's happening here. I'm just going to write BN, bottleneck for short. We basically want to repeat this process for all the different vertices. So I'll go through it quickly. E, we've got 15 and 10 going in for a total of 25, and 10 and 20 going out for a total of 30. Again, another difference, there's 5 excess, but this time there's more on the out than in. And that is what I would call, there's like extra space. Okay, so I'm going to write ES here for extra space. We're going to do the same for D. We've got 20, 30 going in, and a total of 10, 20, 30 going out. So this one's perfectly balanced. So I'm going to say there's no excess. The type, it's irrelevant, right? Normally what this means is D is fine. We're not going to touch it. B, we've got 10, 20 going in, but 10, 30 going out. So we've got 20 in, 30 out. There's a 10 excess, and let's have a look. The extra is on the way out, so we have extra space there. And then finally at C, we've got 10, 20 going in, but only 10 going out. So that's, again, an excess of 10, and this time, we've got a bottleneck. All right. There's a lot of work, but we still haven't answered the question yet. They're saying, which path can be increased and by how much? So currently, the min cut, or the max flow, is 35, and we need to make it to 40, right? So all we need to do is allow 5 more people to get through this network. The way that we can do that is by pairing up a bottleneck and an extra space. Because that means too many people are waiting at one point, and there's room on the other side for people to come through. So if we can fix the edge, or you can think of it as like the path between them, if you make that path a bit wider, now all the people that are waiting at one side can go through and there's room to support them on the other side. So there are actually a few possible answers to this question. So if you look at B and C, they both have a 10 excess, and again, with C having a bottleneck and B having extra space. So that means here, there's people waiting, and there's space for them there. So we can fix the path CB. And by how much? Well, we only need to improve it by 5 people. So we can improve the path CB from 10 to 15 people. And that's a valid answer. Now you might also notice that you can also pair up A and E, which have a 5 excess and a bottleneck and extra space. And that would also be perfectly fine. So you'd go from 15 to 20. Now both of these are correct answers. It's up to you which one to pick. I just went off BC because there's more space to be able to improve it by. Okay. So yeah, that's this question here. I hope you can sort of follow that guide. I know there are a lot of steps to it, so I'd highly recommend just going and practicing a few of these yourself. Best way to do that is just to pull up a bunch of past papers, flick through until you can find sort of a critical path question like this, and then see if it has the improvement. I would say 1 in every 3 papers has the improvement add-on to this style of question. All right. The next one we're going to do is off an advanced paper, and it is an optimization question. So optimization falls under the category of differential calculus, and it is an application. So there's not actually a particular topic on it. But because it's such a big subtopic, you're going to see an optimization question on practically any paper. So I'll give you sort of the general guide on how to answer these style of questions and then how to do this one in particular. So typically with an optimization question, there's what I would call 3 bits to it. Normally in part A, we need to prove some sort of relationship. Okay? And then in part B, we need to make this relationship in terms of two variables. Okay? So a lot of the time, you're going to have 3 or more variables. So let me just show you this question as an example. We've got a few unknowns. We've got theta, the angle, x, the length here, but also volume. So see how we have 3 unknowns, but realistically we only need 2, we need 2 later on. So we've got to somehow eliminate a variable, and we're going to do that by substitution later. And then part C is the actual optimization. Okay, and the optimization we're going to do by differentiating. And when you differentiate, we're going to basically find a max or a min turning point. Okay, and then part D, sometimes they'll ask you to then interpret or like sub in the variable. Okay, so that's the general steps. The biggest advice I would give you is that if you can't do A and B, which tend to be the difficult part of these questions, they always give you like a show that type of thing. So if you can't do it, you could just use the value that they wanted you to prove to go ahead and do C and D. And the thing is, C and D normally carry more of the marks. So A and B might be like 1 or 2 marks, C and D could be 3 to 4. So that's kind of a cheat code. If you can't do the start, just skip to the end, all right, so how are we going to do this question here? So they've told us that we've got a cone that is being made from a curved surface here, basically a sector. And we know that the radius of this sector is 10 centimeters with some angle theta, and we're going to turn it into a cone like this. And in part 1, they want us to show the volume of this cone is given by this here. And notice how it's purely in terms of x. However, we've got both theta and x. So we need to somehow work out how to eliminate theta, like I said before. I'll just shift this to the side so you can refer to the question while I do the working. So they've given us this formula to start with, which is that the volume of some cone is equal to a third pi r squared times h. Now looking at this cone here, we've got that r, the radius, is x. So firstly, I'm just going to replace r squared for x squared, h. Now, what we need to prove only has x. So we need to somehow get rid of h, or find an expression for h and sub it in. So notice how in this cone, we've got a right angle triangle, where that's 10, this is x centimeters, and this is the h that it was referring to. So how can we get something for h in terms of x? We can just use Pythagoras theorem. So we're going to say that h squared is equal to 10 squared minus x squared, and therefore h is equal to the square root of 100 minus x squared. Okay, and then if you look towards here, you can see we're on the right path. Then I'm going to sub that back in here. We're going to say volume is a third pi x squared root 100 minus x squared. And that's it. So that's part 1 done. To end a proof, I would always say something like, as required. All right, so that's part 1. Let's go on to part 2. Show that the derivative of volume with respect to x is equal to that identity there. So it's asking us to now differentiate this. So again, we have volume is a third pi x squared, 100 minus x squared. I'm going to just turn this into indice form for the square root, so a half, just because it's going to be easier with the differentiation. Now, you may recognize that this is a product rule style differentiation, where I'm going to call this u and that bit v. Okay, so I'm going to do a bit of side working here to say that u is a third pi x squared, and u dash is equal to 2/3 pi x. And then we can say v is equal to 100 minus x squared, power of half. And v dash, we're using chain rule to differentiate that, is a half 100 minus x squared times 2x, minus 2x. Okay, that's to the negative half. Okay, I'll simplify this real quick. This is x okay. So to do product rule, remember we're going to do v u dash plus u v dash, or vuv. So we're going to say, dv dx is equal to v times u dash, so 213 pi x, 100 minus x squared, power of half, plus, I'm going to multiply this and that over there. We're going to get 1/3 pi x cubed all over 100 minus x squared. Now, I just used, that's a negative indices, so you can bring it to the bottom. Now, this isn't what they have yet, so we need to somehow turn this into one fraction. I'm going to put the square roots back in just so you can see what's going on. So yeah, when you're differentiating, you always want to, you typically want to put it in that square root form. In the indice form. But when you're doing the algebra, it's easier to just put it back. Okay, so I'm going to multiply both the top and the bottom here by 100 minus x squared. Okay, that's basically just going to cancel the square root. So you can just say 100 minus x squared. And I'm bringing these together as one common fraction. Okay. The next step here is I'm just going to factor out the top. So we're going to get, basically I'm going to bring out 1/3 pi x, so from there and there. And then we're going to get 2 times 100 minus x squared plus x squared all over 100 minus x squared. Okay, and we're going to have to carry over to the next page.
Hey, looks like we have a joiner.
Hey, how are you doing? Welcome.
Oh, and they got
Oh, no.
It's okay.
When they come back.
Also, I'm on a TikTok live. Say hello.
Hey.
Everyone, this is Liam, and he's walking us through a couple of maths HSC style questions. If you have any questions for him, drop it in the comments and he might actually answer them for you. Let us know if you have like absolute trouble reading this, and maybe I can fix up the camera too.
Mm-hmm. And then it doesn't have to be like a math question to solve as well. If you want general advice when it comes to math or studying the HSC, let me know. We can answer that too.
Sure. For now, we'll just continue with where you were at.
Mm-hmm. All right, so now we're getting pretty close to where we were. So you can bring the 1/3 down. And we get the bottom just like they have in the solution there. And then if we expand this, we're going to get 200 minus 2x squared plus x squared. Now, looking forward to the answer, this should also be a minus, which indicates I have made a sign error somewhere. I'll see if I can quickly find where that is. Otherwise, I'll show you the trick that I was talking about before. Ooh. Notice how there was a negative here. I was meant to have it there. So that's going to come into here. Doing the not so dodgy, fixing it up backwards, happens all the time. So now we're going to have pi x 200 minus 3x squared over 300 minus x squared. And that is exactly what they gave us there. So we've done part 2 as required as well. All right? And then we have part 3, which is to find the exact value of theta for which v is a maximum. That's going to require us to set the derivative equal to 0. So we're going to say let that equal 0, and then therefore solving for the values of x. Now notice how this says theta. That's something we want to watch out for. We're going to have to translate x into a value of theta later on. So we're going to say pi x 200 minus 3x squared on 300 minus x squared equals 0. The denominator is not really going to account for anything here. The only thing we have to notice is that x squared has to be less than or equal to 100. And that's because we can't have x exceed 10, because then that would actually be the hypotenuse. So we don't have to worry about this for now, but just noting that's a restriction. So we can therefore say pi x, just the top, 200 minus 3x squared, is equal to 0. Now there's going to be sort of two areas we can get a solution. Here, either that equals 0, which implies x equals 0, or this bracket equals 0, which implies 200 minus 3x squared equals 0. Rearranging this one, get 3x squared equals 200, x squared equals 200 over 3, and then x equals plus or minus root 200 over 3. Okay, now let's just think about it for a second, right? First, if x equals 0, that implies we don't have a triangle, because this length would be nothing. So we can kind of like reject this one here, because x has to be greater than 0. And by that same logic, we can't have x be negative, because that would imply a negative length, and that just breaks physics, right? So we're going to end up with x is simply just equal to root 200 over 3. Now this is what this information is telling us, is that that value of x is a turning point. Now, right now, we don't know if this is a minimum turning point or a maximum turning point. And since the question wants us to find volume for maximum, we do have to work which one that is. Now, because the question is designed, nicely by the HC writers, generally this is going to be a maximum, but we do have to show it. So the way that we can show it there's a few different ways. We can do first derivative test, second derivative test. I am just going to look at the first derivative test because it's going to be slightly easier in this case. So coming over to the next page, we're just going to set up a little table which has values of x, and then we're going to be subbing this into v dash, the first derivative. And three values that we're going to sub in is root 200 over 3, and then something slightly smaller and slightly bigger than it. So if we come to the calculator, root 200 over 3 is approximately 8.16. So let's chuck in 9 and 8. Now we want to set up the equation like we did before. Hey, how are you? Thanks for joining. Can I turn the paper towards the camera? Yeah, let me try and move this around, see if this is going to help.
Hold on.
You going to help?
Yeah, we might have to.
Yeah, I understand. You want to be able to follow the question.
Give me 1 sec. Okay.
You got it?
Does that help? Hello?
Hopefully that should be able to help a little bit. This is the question we are completing as well.
Hold on. Let me actually, what if I just do this? Is
Sure.
that better?
Yeah, that might
Okay.
help. Alright, so we want to set up the equation in our calculator for the first derivative, so what they got us to prove before. Okay, so this is the equation. I put answer in there, and what that means is I can sub in a value for the answer, and it's going to sub it in. So let's take root 200 over 3. See the mistake I made? I put the squared after the brackets. or it should be there. Let's try that again.
Sorry guys, give me one sec.
Just retyping it in. Okay, so what I've just done is I've just subbed in root 200 over 3 and we get 0 like we expect. And that's because there should be a turning point there, which means the gradient would be 0. Now let's try 9. I'm subbing in 9 into the equation and we get a negative number, negative 92. Okay, the exact value doesn't matter there. 8, we're going to sub that in. We're going to get a positive number, 11.17. Okay, now notice we have a positive gradient, a 0 gradient, and a negative gradient. Okay, and that therefore says we have a maximum turning point when x is equal to root 200 over 3. Okay, now this would give you 2 out of the 3 marks. The last bit is it's asking for theta. So we're gonna have to quickly solve for this. Let's find the relationship there. Okay, the way that we can find this relationship is, I guess, looking at the circumference of this circle and then connecting that to this length here. So in general, circumference of a circle is equal to 2 pi r, so the diameter times pi, which is going to be 2x pi. So this is the circumference. Okay, now this circumference is equal to this arc length, right? And the arc length is equal to pi over 360 times whatever the Okay, so this one here, like the theoretical circumference would be equal to 20 pi, so 2 pi r. Now, because we're only taking a portion of it, we're taking theta on 360 of the circumference. Okay, so now we're going to let that equal to this. So we're going to say 20 pi theta on 360 equals 2 pi x, and remember x is root 200 over 3. I'm going to start simplifying this. Okay, we can cancel out the pi as well. So we have 10 theta on 360 is equal to root 200 over 3. So that means theta is going to be equal to 360 over 10 root 200 over 3, which is equal to 36 root 200 over 3. All right, that one was a bit of a workout to get towards the end. But even if you just were able to prove this is a max turning point there, you would have gotten 2 out of the 3 marks. So yeah, that's that question complete. I'll leave that up for a moment if you want to just have a look at the working. And then let me know if anyone in the TikTok, oh sorry, is it Instagram or TikTok?
The TikTok.
The TikTok, if anyone has any questions you'd like me to chat about before we do another math question, let me know.
We'll wait for a second.
Yeah, no worries.
Let's see, that has to be really fast. Show them.
Maybe if you just put it on top of this.
I was trying that. It's a little unsturdy.
And then you also can't read the question.
That's fine. Sorry guys, we're clearly amateurs at this. Alright, I'll give it a sec. One person at the moment.
the last question we're going to do is from an extension 1 paper. Before we do that, does anyone have any questions? Thanks, Emma.
So helpful. Oh, awesome. Okay.
And
Emma.
we'll also give the full recording of this afterwards.
Yes, it's on our Discord if you join.
Yeah, if you join our Discord server, you might get some.
No. Oh, I'm such a boomer. There we go.
Sorry, guys.
Sorry.
Yeah, we're gonna release the full recording of this session on our Discord. So if you want to like follow along from the start and see the exact questions we were answering to, feel free to check that out after.
Mm-hmm.
So the last question that we're going to go through is extension 1 question, and in particular, it's a vector question. Now, vectors are quite, notorious in extension 1. They are normally quite difficult, and I picked this one in particular because it's a little bit different than the average question you would see. It has a lot of physics background to it. So as someone that didn't do physics in high school, I'm going to show you sort of my perspective on how you would do this question. So what they've told us is we basically got some sort of ramp with 2 objects hanging on a pulley. So we've got A and B sitting on a pulley. And everything's at rest, which means nothing's moving. And in particular, they're telling us that this here is 8 kilograms, object B is 5 kilograms, and gravity is acting at 10 meters per second squared. Right? That's the setup. This ramp's at 30 degrees incline, and we just gotta play around with it, right? So what they've told us is, in general, that the magnitude of the tension force on object A, so T1, is equal to T newtons. And the normal force on object B, which is acting in the center of B, I probably should put in the middle, is equal to this. Right? And we're going to end up using this, right? So in part 1, they want us to express tension 2 in terms of T in column vector form. Now, the way we're going to do this is by setting up free body diagrams. So because nothing's moving, we can therefore say that the magnitude of tension 1 must equal the magnitude of tension 2, which is T newtons. And if we're looking at the tension force at B, it's acting this way, right? At an incline of 30 degrees. So this is coming from this diagram up here. I've just brought it over here. Now, what they're wanting us to do is put it into rectangular components. So basically, what is the vertical force and what's the horizontal force? And the way we can do that is by breaking it down this way and this way. Okay? And we will get that in the horizontal direction, or in the x direction. This force is the magnitude of T2 cos 30. Okay, so this is how we break it down horizontal. And we're going to define that upwards is considered positive and rightwards is considered positive. And also, notice that that's defined here as well. So because this is acting in the left direction, this is going to be negative. Now, we already said that the magnitude of T2 is T, so this is minus T. And cos 30 as an exact value is root 3 on 2. Okay, so therefore, in the I direction, or horizontally, it's equal to minus T root 3 on 2. If we're looking in the vertical direction, it's going to be magnitude of T2 sine 30, which is equal to T times a half, or T over 2. And that's just using the exact value there. So therefore, T2, the vector, is equal to minus root 3 on 2 T in the horizontal direction, and T over 2 in the vertical direction. And that's the answer for part 1. Now, they only give you a mark for that, so it's a little bit annoying. Alright, secondly, we're going to go into part 2, which is to find the values of T and N, which is the tension force and n, which comes from the normal force. And the way we're going to do that is by considering all the forces that are occurring on object B. So let's set up another free body diagram. I'm going to do that over here, and this is at B. Now, we've got a few forces going on. Firstly, like we just defined before, we've got the tension force, T2. We've also got...
Sorry, someone said please do some for the standard course as well, because they're confuzzled.
That's pretty reasonable.
Yeah. Well, look, we'd be happy to go through a standard question. If you have anything that keeps tripping you up at school, let us know and Liam can walk us through that.
Yeah, if you're able to give us either like a topic or just a question that you've got, I'll run through it.
Okay, but in the meantime, feel free to continue.
Sure. Alright, so we've got the tension force happening in that direction. We've got the normal force happening perpendicular to the surface. So I'm going to call this N2. And then finally, we've got gravity, which is always going to be happening downwards. So this will be the weight force. Now, these should all sum up to 0 because this is at rest. So we should say that the tension force plus the normal force plus the weight force equals 0. Now, to solve this, we're going to split it into horizontal and vertical components. So let's start horizontally. So we're going to split each of these into its components. We said before that horizontally, this is the T2 minus root 3 over 2 T. Okay. From the question, they've defined the normal force at B horizontally to be N over 2. Okay. And the weight force is purely occurring in the vertical direction. So it's going to be plus 0 here, and this equals 0. Now we can let this be a simultaneous equation. I'm just going to say that N is equal to root 3T. I'm going to save this equation for later. If we're looking vertically, let me know if we get a question. We're going to take these things again from part 1. From the tension, we get T over 2. From the normal force, we're going to get root 3 over 2N. And from the weight force, this is going to be downwards because it's acting down. It's going to be gravity times weight. So it's going to be minus 10 times 5 kilos, which is what they told us, or minus 50. So I'll just change that to minus 50. And this also equals 0 because nothing is moving. So we can get here that T plus root 3N minus 100 equals 0. And we're going to make the substitution from up here to get T plus root 3 times root 3T minus 100 equals 0. And we're going to get T plus 3T equals 100. 4T equals 100. T equals 25 newtons, because that's the unit. We've now solved for T. We just want to solve for N as well. We can do that by subbing back in. N is root 3 times T, which is now 25. So 25 root 3 newtons. And there we go. We've solved part 2, which is the hard bit of this question. And then going into part 3, it just wants us to find the components of N1. Now, I'm going to save these values. We'll come back to them. I'll get a blank sheet of paper. If we're looking at over at A, these are the forces that we have going on. We have the weight force, which is 10 times 8, so 80 kilos going down. We have the tension force, which going up is T newtons, or we just solved 25 newtons. And we also have the normal force going up, okay? And this is N1. Now, again, this is not moving, so all of these have to add up to 0. So we can say N1 plus 25 minus 80, because 80 is downwards, equals 0. We can get N1 is equal to 80 minus 25. N1 is equal to 55 newtons. Now, the question specifically says the components, so we need to put this in horizontal and rectangle, and vertical. So this is going to be N1 is equal to nothing horizontally, 0, and then 55. And that's it. All right. So yeah, that's how to approach a vector question when it's sort of in this real physics style. Feel free to have a go at this one by yourself now that you've watched the tutorial. And yeah, we'll go from there. So now we're going to answer any questions that the people watching live have. And it doesn't have to be a math question, like as in like from a past paper. If you just want to chat about, a particular topic, or if you just want to ask for some general study advice or anything like that, just let me know. Is it your best studying on the weekend when you don't have any school to worry about? Or do you want to save the weekend, for fun stuff and have a break? I would try doing things like writing notes or maybe using flashcards, or any study technique that you hear about. Give it a crack in year 11 and find the ones that work best for you. Because when you're in year 12, you want to have that stuff already sorted so you can focus on actually learning the content. You don't want to be figuring it out for the first time when you're in year 12, because of course everything across that year is going to matter.
Mm-hmm. And Liam was a state ranker, everyone, so has definitely had his fair share of HSC prep, I feel.
Yeah, probably too much.
What would you say, what type were you? Were you the one to study 24/7, 7 days a week?
Okay, 24/7, 7 days a week, nah. No, I definitely put in the effort,
yeah.
But you're not going to get there if you don't give yourself a balance.
Mm-hmm.
So I quite enjoy sport and exercise. So I was doing exercise once a day at least. So whether that was, playing as part of a team, going to the gym, going for a run, any of that is something you want to balance in, because if you're just studying, you're definitely going to burn out.
Yeah.
We had a question from Leah. What degree am I doing? I'm currently at Sydney Uni and I'm doing a double degree. I'm doing biomedical engineering and commerce, and my major in commerce is finance. I'm in my 3rd year, and this is a 5.5-year degree, so it's meant to end in another 2 years, but I think I'm going to wrap up next year with just the commerce degree. yeah. It's definitely been shocking, but it's been fun. If you're thinking about doing any of that stuff or curious about what uni's like, let me know.
For sure. I think we might stay on for a little bit longer and then we'll wrap up.
Sounds good.
If that's okay with you. Any other questions from... Do any of you do tutoring?
Hey Millie, thanks for joining. Sorry.
Oh, hi Millie. Just waiting for any questions for Liam. It can be to do with the HSC, to do with school itself, to do with math. He's really good at math.
Nah.
Don't be humble.
Hey Joanne. One thing I would say is that tutoring is really helpful at teaching sort of the tips and tricks you might not get at school. Especially, when you're learning at school, they're catering to, a whole class of people. That means it's going to be a wide range of students.
Mm-hmm.
When you have tutoring, you can be a lot hyper-focused on what you're looking at, and also someone that's able to cater, to your needs as a student. So that's definitely one of the advantages, I would say.
Yeah. What was your favorite math topic at school?
Favorite math topic? You know what? Okay, this is going to be a bit nerdy, but I did Extension 2,
mm-hmm.
and the one I liked the most was probably proofs in Extension 2. I don't know, it gave me a bit of appreciation for how things come together and how to test a theory.
Mm-hmm.
Okay. Sounds so nerdy, but I know I really liked it. And then I feel like that's helped me as a tutor, because you kind of get a different perspective on
how to explain something.
How to explain stuff, exactly. And yeah, giving an answer that's concrete and not just, I guess, a concept.
Yeah, for sure. Do we have any other questions for Liam before we wrap up? No.
Hey Max, thanks for joining. We're just opening to the floor if anyone's got any questions about the HSC, about uni, about tutoring, anything like that, let me know.
Let's think of something to ask you. What would you say is like the thing that your like students at tutoring ask you the most? Do you get a lot of questions about uni, or is it more just like how to get through school?
Good question. I would say one of the things I get asked the most is like, I guess where do you like find time to revise?
Yeah.
And I would just say I never really made like studying like my first priority on my calendar. It was more so I would fill out my calendar for like maybe the week of like the stuff I was planning to do, and then I would just put in like time to revise between them. So if you have some mates saying, hey, let's go out, you know, Friday night, we're going to go to the shops, or if you've got a dinner or you're going out with your family on the weekend, I would always prioritize that stuff first, and then you can work around that to do a bit of work. If you're planning to go to dinner, you might have an hour after school to be able to look over something. If you know you're going out on Friday, maybe Thursday is the day to go into some work. So I think making sure you prioritize the rest of your life first is the way to go.
Yeah, no, I agree. I feel like I just prioritized the TV shows and
The TV shows?
No, but I also did very different subjects, so you know.
Yeah, no, I watch a lot of TV shows as well. That was like my way to wind down as well at the end of the night.
Yeah.
Love doing
exactly. And I think like when you're at school, you have to give yourself a break. You've been there for 6 hours already, and then you come home and it's just not humanly possible to just go straight back into it like immediately. But as Liam said, I guess it's just time management.
Yeah, I think super common as well. As soon as you finish school, like just going home, doing some exercise, whether that's playing sport or going to the gym, that's a good break as well. And then when you get home and you've had food, then you can like have another crack at doing some work.
When I was in year 12, I like had to mandatory take naps once I got home. I was never a nap person.
Yeah, I've been there.
But year 12 did that to me. Anyway, it looks like that's kind of it for today, everyone, unless you have any other questions for us. Ali, I think you're the only one here. Oh, and
Curtis.
Hi. If you have any questions for Liam about the HSC, about math, anything like that, let us know. But we are hoping to wrap up soon.
Yeah, probably.
Unless you have a question.
Yeah, probably got time for like one more question.
Yeah.
Happy to go through that, and then we'll leave you to it.
We'll just hang around for a little bit. Was that fun? You look like you were having fun.
Having fun, maybe.
A little bit. It's okay to be nerdy.
Wait, who said that? Who said that?
Who said that? One time I was talking to Rosie, and she was like, oh, I'm like 24 or 23, and I was like, it's okay. And she was like, what does that mean? Any questions? Have you seen the I make the face, you make the sound thing?
Yeah.
Let's do it while we wait.
Okay.
Okay. You have to make the face, I make the sound.
I don't know this.
Unless you guys ask us a question.
Yeah, please save it, please.
Save Liam. Hashtag release Liam in the comments down below. Go ahead. Just one.
No. I'm actually not doing this.
Okay, I think we'll wrap up then. Thanks guys for joining. Did you have anything else you'd like to say before we finish up?
Yeah, I'll just remind you guys, we put the full recording of our session today on our Dimix Guru Discord. So I recommend going there. We put all the questions that we did as well as a PDF. So you can run through those questions and then basically use my explanation as either solutions if you want, or use it to follow along if you're doing it for the first time. So yeah, thanks for joining, guys.
Thanks for joining.
Hope you have fun, and we'll see you later.
Bye.